In section 6.3, we have logarithmic functions. A definition of a logarithmic function. A logarithm base b of a positive number x satisfies the following definition for when x is greater than 0, b is greater than 0, and b does not equal 1. We would read the statement as y, which is equal to the log of base b of x, is equivalent to base b to the power of y, which is equal to x. Now, if we look at this equivalency here, these are both meaning the same thing. Okay, you can convert this logarithmic equation into an exponential function. So if you look at this exponential function, we can read this exponential function as y is the exponent on the base b. The equal sign is to get x. So we can reread it the same way on this side. We can say that y is the exponent on this base b to get x. So if you read that to yourself a few times, it's going to make a lot more sense and easier for you when you start translating this information. So make sure you take a look at that quote. Now we're going to read again the log of base b x as the logarithm with base b of x, or the log base b of x. And the logarithm y is the exponent to which b must be raised to get x. Also, since the logarithmic and exponential functions switch the x and y values, the domain and the range of the exponential function are interchanged for the logarithmic function. Therefore, the domain of the logarithmic function with base b is going to go from 0 to infinity, whereas the range of the logarithmic function is going to have it with base b is negative infinity to positive infinity. So for example 1, we want to be able to convert from logarithmic form to exponential form. So how do we go about this? If we're given an equation in logarithmic form of log of base b of x, which is equal to y, we're going to convert it to exponential form. So step 1, we're going to examine the equation y, which is equal to the log of base b of x, and identify b, y, and x. And then we're going to rewrite it in step 2 in the form of exponential form. It's going to go from b to the y power, which is equal to x. So we're going to write the following logarithmic equations in exponential form. So if we take a look at a, we have the log of base b of the square root of 6, which is equal to 1/2. So when we're looking at this particular equation, we're going to compare it to the general form of a logarithmic form. So the value of b is the base, so b is going to equal 6. We know that the exponent is 1/2, meaning that y is equal to 1/2, and therefore x is going to equal the square root of 6. Therefore, the equation of the log of base 6 square root of 6 is equal to 1/2 is equivalent to the following. b is the base, 6. We're raising it to the power of y, which is 1/2, which is equal to the square root of 6. And again, we're using that form, b to the y power, which is equal to x. Let's do the same thing in part b. We have the log of base 3 of 9, and that's equal to 2. So here we know that b is equal to 3, so the base is equal to 3. We know the exponent y is equal to 2, and the value of x is equal to 9. So therefore, this logarithmic equation is equivalent to the base of 3 with an exponent of 2, and that's equal to 9.